Welcome to the course on relational databases in SQL. This course will provide you with the foundations of the SQL language, which is a standard language to query and manage data inside of relational databases. You will learn how to query databases, relational databases, how to manage data inside of them, how to understand database schemas and design, and also design some simple schemas yourself. You will develop some foundational skills for data analysis and overall programming. And also you will set a foundation for advanced learning and learning some more should you desire to do so in the future. Before we begin, I should probably tell you why would you learn SQL. So SQL is a vital language if you want to learn data management. It opens up career opportunities, it opens up data-driven decision-making opportunities, and it's universally compatible with all kinds of database management systems that are relational, including MySQL, SQL Server, and others. It allows us to manage and query relational databases. It provides us with career opportunities as developers, as data analysts, as data scientists in software, and even if we want to become database administrators, it's also necessary. It also allows us to extract insights from datasets, and this is why it's so vital. So before we jump into SQL, we should probably understand what we can do with it, right? So before we begin, I should backtrack a little bit and tell you what a database is. A database generally is an organized collection of data related to one another. An example would be a phone book, a collection of books or movies, a library catalog system or any other catalog system, a product database in an e-commerce system in an online shop, a database of patient records in a hospital, and so on and so forth. The concept here is that you have related data classes. So a phone book may have full names and also phone numbers. A collection of favorite books may have authors and book titles. A library catalog system would also have books and their authors, right? A product database would have a product, who purchased it, when, and what username probably they're logged in as if you're buying online, right? A database of patient records may have a patient name, surname, his history of illnesses, and so on and so forth. There are multiple types of databases. There are relational databases, non-relational databases that are called NoSQL databases, and object relational databases. In this course, we will only cover relational databases such as MySQL and Microsoft SQL Server. We will focus on MySQL for this example. There are all kinds of other databases such as MongoDB and Redis, and these are called non-relational or NoSQL databases, and they work based on basically available and eventually consistent principle. That means that your data will be highly available, but not necessarily always consistent. Relational databases work on the ACID principle, which is atomicity, consistency, isolation, and durability. And this principle makes your data reliable even when your electricity goes out in the middle of importing data, or so on and so forth. Object relational databases work a little bit differently, and this is where we have such databases like PostgreSQL, but we will not cover this in this specific example. So what is SQL? SQL usually refers to a structured query language, and it allows us to create database structures such as tables, databases, and schemas, and add new data inside of tables to query them. It allows us to read or select data within tables that reside in databases, retrieving existing data. It allows us to update data to change existing data, and it allows us to delete data from a table or a database. We can also drop databases and remove tables. Real-world applications of SQL include e-commerce sites, forums, banking and finance, social media, and so on and so forth. Basically everything you use in some way, in one way or another, is using relational databases, whether that would be YouTube, Facebook, Twitter, and so on and so forth. Applications may use a variety of different databases to reach their goals, but there's a good chance that something you use uses MySQL or other relational database management system in the process. Now we will set up the environment for learning SQL. We will base our learning on MySQL and one of its flavors, MariaDB. First, we'll need a database management system. We will use MySQL, which is widely used and free. To download MySQL, head over to mysql.com, then click on Downloads. scroll down, click on MySQL Community Downloads, then click on MySQL Installer for Windows, select your version and download MySQL with the installer. You can download with signing up or without signing up, it's optional. Once you have downloaded MySQL, it's time to install it. In my case, MySQL is already installed in the system, but in your case, you will need to specify the password for the administrative user root and follow the prompts that you're given. Afterwards, remember the password, because that password is what you will use to connect to MySQL and you will be good to go. Now that you have installed MySQL, it's time to interact with it. To do that, find the MySQL command line client using the search bar on your operating system, then open it up and type in MySQL u root. If you have a password, MySQL will prompt you for a password. If not, you should see something similar to this. If you see something similar to this, it means that MySQL or MariaDB, whatever you installed, is working and we can move on. Now that we have installed MySQL, it's time to start working on it. We work with database management systems, including MySQL, with something called SQL or SQL clients. These are appliances that help us better understand our database and help us better interact with it. One of them is DbVisualizer, which I will be using in this example. There are other SQL clients that you can use, such as DBeaver, PopSQL, and the like, but I will be using DbVisualizer for this example. So once we launch DbVisualizer, we will see that we will be able to create a database connection to connect to our database server. I will also state that not all SQL clients are the same, in that some SQL clients will necessitate you to have a server to connect to, and others will allow you to connect straight to your database. So in my case, I will be searching for MariaDB because I will have a server that I installed MariaDB, which is a fork of MySQL on. So once I select MariaDB, again, this is a fork of MySQL and this is installed on a web server using Windows, using WAMP. We'll see that we have a driver type, which is MariaDB, the database itself, the database server, which is localhost, the database port, which can differ. If you're using MySQL, it will be 3306. If you're using MariaDB, it will be 3307, just a number difference. And then the database user ID will most likely be root, unless you define it otherwise. And your database password will be a password that you have defined. So let's connect. We see that we have successfully connected to MariaDB, to our database, and that we can start working on the database itself. Right, so to begin working with a database, we need to issue SQL queries. With this SQL client, we can do that using SQL Commander, which is a place where you issue SQL queries. It's called an SQL editor or an SQL client. SQL clients allow us to create databases, tables inside of them, and interact with the data we already have. Now, to have data inside of our database, we first need to create a database. Within MySQL, we create databases with the create database queries. So that's create database, then the name of our database. So we will call this demo. And once we execute this query, our database should be created. We see that one query has been successfully executed, so we have a database called demo now. Now, once we have a database, we need to have tables inside of the database. We create tables inside of MySQL by using a create table query. So that's create table demo. After we issue this query, we need to create the structure of our table. So what we'll do now is we'll decide on a structure of our table. That means we will have columns inside of the table, and those columns will have definitions. So one column will be, for example, ID, right? So ID. Then we will have a definition called not null, which means that you cannot store non-existent null values inside of them. I'll explain what it means in a second. And we will have auto increment. I will explain what these mean in a second, and then we'll have a second column. Let's call it data. Let's make it have varchar data type, and let's make it not null again, and let's make it have a default value of nothing. And let's make our integer, let's make our ID column have integers inside of them. So what we did now is we told our database that we want to create a table called demo with 2 columns inside of them. So one column will be called ID. It will contain only integers of 10 characters long, of up to 10 characters long. These integers cannot store null values. Would mean null values mean absolutely basically nothing in our database. Auto increment means that any value inserted in that column will increment automatically. Basically that this column will increment automatically even if no value is inserted. And a primary key is a precondition to the auto increment value for the column to increment automatically. This is usually done in forums, in content management systems, in social media systems, to basically have a track, keep a track of how many rows are in a table by associating every row in a table with an ID. So what this does is allows us to keep track of the rows in our table by assigning them an ID that increments automatically, as you can see here. Now the second column we have here is data. We will make it have variable characters, which mean all kinds of symbols, letters, numbers, and stuff like that. We will also tell MySQL, our database management system, that this column cannot be null. It cannot contain null values. This is optional. You may skip that if you want. And we will also have a default value of nothing for this specific column. So once we execute these kinds of queries, we will tell our database that we want to switch to the database we just created by using the use statement, then create a table inside of that demo database that has a structure like so. So let's execute the query. And we will also see that both queries have been successfully executed. So what we did now is we created a database, we switched to that database using the use command, and then we created a table with the create command. Right? Our table has a very simple structure with 2 columns. Most tables within relational database management systems will have significantly more. Anyway, now that we have a table, let's start working on it. Now that we have created a database and a table inside of it, it's time to start working on it. We work with databases and tables inside of them by inserting, updating, deleting, or selecting data inside of them. So what we'll do now is we will create something inside of our table. So to create something, to insert data into our table, we use the insert into statement. To select data, to read data, we use the select statement. To update data, we use the update statement. And to delete data, we use the delete statement. We will start with the insert into statement. So we will start with the insert into statement by defining where we want to insert the data. So we will define the name of our table. Then we will define the names of our columns in these parentheses. So we will need to insert data into ID and into data column. Next, we'll have values that we will insert into that table. Right, so within those values, we will have one null value, which makes the ID column increment automatically because we defined an auto incrementing property inside of that column. And we insert data into our data column with the value of demo. So what we'll do now is we will insert data into our demo table. into two columns within the demo table with values of null, which makes the ID column increment automatically with ID values. So we'll have an ID of 1 for our data column, and we will insert data into the data column with values of demo. Now I will also stress that if you insert into all existing columns inside of the database, you may skip this part. You may delete this part altogether, but for the sake of completeness, we will execute this. Some SQL clients will also alert you in regards to permissions. So DbVisualizer does that as well, but once we continue, we will see that now we have one row inside of our table, inside of our database. So to know what data we have inside of our table, we use the select query. So the select query makes it possible for our table to show data to us, in other words. So we will now view all of the data inside of the table. So select all, a star means everything, from our table. So with this, we tell our database that we want to select all rows, everything that it entails, from a certain table, a table called demo. And since you see that we are in a database called demo as well, our query will connect to the database called demo and then select everything from a demo table, and then we'll display it to us. So we can see that we have one row with two columns in a table, right? So our ID column is 1 because once we created a table, we defined the column like so. Our definition was like this. So we define an ID column. Once we created our demo table, we defined an ID column and told our database that it increments automatically, and it also has a primary key inside of it. So basically a primary key is something that you see here, and it makes the column increment automatically, as you can see here. We did not submit any data into the column. We submitted a null value, which means nothing in terms of databases. But since we defined our table like this, it incremented automatically. And the data column was defined with a variable character value, which means everything, including strings, including letters, including characters, including numbers, everything goes into it. Since we defined it to be not null, not to accept null values, and have a default value of nothing unless we insert something into it. Since we inserted a demo value, it has a demo value. Great. So to select specific values, we use the where clause, which filters our selection, right? So we tell our database with the where clause what we want to select exactly. So for example, in this case, we can either act on the ID column or on the data column. So we will say that we want everything where an ID, which is this column, is equal to a value in this column. So we only have 1, so we'll define 1. And the outcome should be the same because the only row, the only data we have is this in the table. So to update the values in the table, we use the update query. With the update query, we also specify the table. So update table, set column. So we set our data column to something, and then we issue a new value to the database. So new value, let's say it like this. You can have anything inside of it. We just use it for demo purposes. Now our data should be updated. So Let's now check again with this query, the same query. Again, we select everything from a demo table inside of a demo database that has an ID of 1. We filter down the available values with the where clause. Once we execute this query, we see that our data is now updated. We have the same column of ID, which is 1, and the data, which was demo, now is called new value. So let's insert some other data for the sake of example, and we'll move on. So we insert data using the insert into statement. Insert into the demo database. We will not specify columns in this example because we will insert data into all of the columns. We'll only specify the values we need to insert. First, we'll need to specify the null value because the ID column increments automatically, so we don't need to specify a value for that. We'll specify null, and then we'll specify some values we need to insert. We will copy and paste these insert into statements to insert more values. So let's do that quickly. You will see that we inserted 5 other rows. So now, once we select everything from the table, we will see that we have multiple values. Once we filter down those values with the where clause, where ID is, for example, 2, in theory, we should get everything that has an ID of 2. So in this case, we will only see this value. So we will only see the ID of 2 and the data of demo. Let's try it, and we'll see that this is in fact the case. Now to delete data, we will need to use the delete statement. So let's select everything that exists in a table again. Once we will select everything that exists in a table, we will see that we have multiple values. Some of the values, let's assume we don't need. So to delete those values from a table, we use the delete statement. So we say delete from our table where we filter down values with where, let's say ID equals of 1. So what this does is it deletes everything from a demo table that has an ID of 1. How the delete statement works is that you specify a table name after the delete from statement, and then you filter down the data you want to delete. So we said that we want to delete all data from the demo table that with the where clause that has an ID of 1. So in essence, we need to delete this row. So let's try it. We can see that we successfully deleted our row, our data. So again, let's see what data we have now. Select all from demo. Again, this selects everything from a demo table inside of a demo database. And we will now see that our ID starts from 2 because we just deleted 1. Again, we can delete another row, delete from demo where data equals to value 2. What this does is it will delete this row. So it will delete the third ID with the data. Right, so we said to our database that we want to now delete everything from a demo table where in the data column we'll have a value of 2, a value 2. So since we only have one value in the table, we will only delete this part. So we will execute this and we will see that this is now gone. So what we did now is we deleted data And then we selected everything from a demo table again to see what data we deleted. So this is the crux of the so-called CRUD queries: create, read, update, and delete queries that allow us to create data, to insert data into our tables, to update data, and to basically delete data. We use the create statement to create a database or a table, insert statement to insert something inside of a table, update statement to update something inside of a table, and the delete statement to delete something from the table with the where clause. The where clause allows us to basically filter down the data we want to act on. Now, to filter and sort data, we have a couple of options. We can use where, and, or not, order by, or limit. We'll go through all of those now. So what we'll do now is we'll create a simple employee table with a couple of records. Once we created a table, we can now start filtering data out. So let's see what data we have in the employees table to begin with. We have employee, department, and salary, right? So to filter data out, we can use a where clause, which we already went through. So where clause filters data out according to some conditions. So for example, if we want to return everything related to Todd, we will tell our database where employee equals to Todd. And here we see that we have an employee called Todd in the Department of Marketing with a salary of 40,000, right? Now we select everything from the table once again. Now, if we want to use the AND clause, we can say where, we must use where department equals to marketing and salary is more than, let's say, 40,000. What this does is it selects everything from the employee table in the Department of Marketing where the department is equal to marketing and the salary is above 40,000. So what this does is it returns all of the records inside of the database that have a Department of Marketing and have a salary of more than 40,000. Great. This is how the AND clause works. We also have the OR clause, which works in a similar way. So we have to define a department where department equals to, let's say, sales, or salary equals to 60,000, let's say. So what we'll do now is we will select everything from the employee table inside of the demo database that has a department of sales or a salary of 60,000. So our database will return everything that has a department of sales or a salary of 60,000. So we will see that we have two rows here, two employees that work in the department of sales. So if we come back and if we want to employ the OR clause once again, we can say select all from employees where employee equals to Jack or employee equals to Sarah. So what this returns is everything related to Jack and everything related to Sarah. And that happens because we tell our database that we want to select everything from the employee table inside of the demo database where employee is Jack or employee is Sarah. We also have something that's called not, and that negates a clause. So in this case, if we will say where salary equals to 40,000, we will get everything, every row that has a salary of 40,000. But if we will include not as part of it, we will get everything that doesn't have a salary of 40,000. So if we will include where, we will get everything that has a salary of 40,000. If we include not, we will get everything that doesn't have a salary of 40,000. This basically negates everything. We also have something called order by. So order by, it allows our database to basically order data in a specific fashion that we specify. So for example, if we want to order by salary, so if we tell our database to select all from the employee table and order everything by salary, that means that by default our database will order every row according to the salary by increasing manner. So we can also specify whether we want the data to be ascending with ask or descending with desk. So by default the data is ascending, but if we specify desk, we will have descending data. So from the biggest row up to the smallest row, so from 80,000 to 40,000. If we specify ask or not specify anything at all, you will see that we have 40,000 to 80,000. We also have something that's called limit, and limit is used to limit the amount of data accessed by a database. It's mostly used if we have a lot of data and we only want to access a small part of it. So if we come back to the employee table, if we say limit 5, we will only get the 5 rows from the top here. As you can see, we only got 5 rows, so 1, 2, 3, 4, 5. If we say 1 and then 5, we will instruct the database to basically return 5 rows starting from the first one. Now instruct our database to return 5 rows starting from the second one, and so on. If we, for example, say that we want to limit 0 and then 3, since database start counting from 0, we will return the 3 rows from the top. As you can see, Todd, Jack and Sarah. If we want to return 1 row, we can say limit 1 or limit 0, comma 1. It's the same thing. Now we say limit 1, we'll say that it's the same thing. So this is how filtering and sorting data works. We can use where, and or not, order by, or the limit clause. So if we have data that we want filtered out, we can use one or more of these clauses. So let's craft a query that would make use of more than one of those clauses. So let's say we want select everything from employees where the department is marketing and the salary is above 40,000, and we only want one result. So let's say limit 1. So what this tells our database to do is to select every data we have in the employees table that has a department of marketing and that has a salary of 40,000. We will see that we have only one employee, Jack, in the department of marketing in the salary of 45,000. This returned one row because we told our database that we want everything from the employee table that has to do with department of marketing with the salary of above 40,000 and only one row. So this is how filtering works. Now we step into aggregate functions and grouping. We'll have count, sum, average, minimum, maximum, and group by. So we'll start by, again, inspecting the employee table. We have 8 records. So if we employ count, we employ it like so, we will then be able to see the overall count of rows in the employee table. We will see that the count of the rows is 8. We can also employ count by column. For example, if we issue count department, we will see that the rows associated with the department column is also 8. If we come back, we'll see that the department has also 8 rows. So this is how the count function works. To step into the sum function, we will sum up something that has a numeric value. So we'll see that if we sum up the salaries from the employee table, we'll have 465,000. If we select the salaries itself, we will select 8 rows of data that has salaries, right? But if we select sum, if we sum up everything in that column, it has to be a numeric column, otherwise this wouldn't work. We'll have close to $500,000. If we employ the average function, which is the AVG, we'll see that the average salary is just over $58,000. The same with minimum and maximum. They have to be applied on numeric columns, not only on salary. You will see that the minimum salary we have is 40,000 and the maximum salary we have is 80,000. Now if we come back to the employee table, we can also employ group by, and this is what we'll do now. So to explain group by allows us to group pieces of data together. So if we have select all from employees and we say where department equals to marketing, group by salary, we will see that we will have all employees in the marketing department grouped by salary in an increasing manner. We can also say that we want a decreasing manner, descending manner, and we will also see that the salary is from the biggest to the smallest. We can also employ a group by having clause. So if we say select all from employees where department is marketing and group by salary like we did now, but we want employees that have a salary of 30,000. So we'll group by salary in an increasing manner where the salary is above 30,000. So this is how the having clause works and how the group by clause works. We will have employees that have a salary of above 30,000 and the department of marketing, and the salary is grouped in an ascending manner because we didn't specify otherwise. Now we have subqueries, aliases, indexes, transactions, and rollbacks. So to begin with, a subquery is a query that has a query inside of itself. What you see here is we select an employee department from employees where salary is more than the average salary of employees. But we do that by starting another SQL query within the SQL query that we already have, making it a subquery. If we execute that query, we will see that we have 4 employees across 2 different departments. So that is a subquery. Aliases work a little bit differently. So if we have select all from employees, if we say select employee from employees, we will have all of the employees within our table. But if we say select employee as worker from employees, we will rename the same column to worker. The result set will be the same, but we'll just rename the column to worker. And this is what aliases do. Indexes help our database quickly find data by acting as a data structure. So let's say we have an employees table that looks like this, right? We have 8 people. To necessitate an index, this table has to have millions or even hundreds of millions or even billions of rows. If we have a lot of rows, we can add an index to a table, and we do that by saying alter table, our table, right? Add index, index title, index name, right? And then the column we want to add an index on. What this does is it tells our database that we want to change the table of employees and add an index having such a name on such a column. So we will see that we successfully added an index. Now, if we issue a show indexes from employees query, we will see that we have one index. The index name or key name, it's a synonym, is an index title. Column name, the column that the index is on, is employee. And cardinality is 8, which means that the index has 8 unique rows inside of it. And the index type is B3, which is the default index type in MySQL and MariaDB. So this is important because if we run queries like select all from employees where employee equals to Sarah, our database will now use the index and quickly find rows. So if we say explain, which makes our database explain how the query is executed, we will see that our database has a simple select type. It has a select query here. It acts on the table of employees. Possible keys, which is possible indexes. It has index title as a result. Possible key, which is the index that's used, is the index title, which we just added. The index length is 102. It's basically a length of characters, and we have one row as a result. So the explain clause in MySQL database management system explains how the database came up with results. So here we can see that the database has actually used the index. In our case, in this specific scenario, the index doesn't do much because we don't have enough rows to necessitate the index creation. But if we have millions or even billions of rows, indexes will be very necessary. Transactions and rollbacks are a different beast altogether. So every query that you send to a database is usually a transaction. Every set of queries is a transaction. So we can tell MySQL that we want a transaction to start by issuing start transaction. Then we issue all kinds of queries that we want to execute. And if we want a transaction to end, we use commit, which basically saves the changes inside of our database. If we don't want the changes to be saved, then we use rollback. So what's going to happen if we run a query like this is that our database wants to start a transaction. It will start a transaction, right? We issue start transaction. It will update the employees table and set the employee to Sarah 2, where employee is Sarah, so it will find this row and change the employee name to Sarah 2 instead of Sarah. And since we actually also use the rollback feature, we issue a rollback here. Our changes won't be saved to a database and they will roll back. So we use rollback to remove the changes given by a transaction, started by a transaction. So if we issue a query like this, we will see that all 3 queries successfully executed. And now if we select everything from the employee table, we shall see that no changes have been made because we set the Sarah employee to Sarah 2, but actually rolled back our transaction. Let's see how it works. We'll see that the employee is still Sarah, but if we do the same thing, just instead of rollback at commit, to save the changes inside of our database, we will execute the query and then select all from employees. We will see that we have Sarah 2 instead of Sarah because the changes we made were actually saved to our database. So commit saves changes to a database and rollback rolls them back. It doesn't save them. Queries by default are transactions. Now you know your way around SQL. You can build applications supporting simple data retrieving operations. You can retrieve specific information from a database. You can filter data based on specific conditions like where. You can insert, select, update, or delete existing data. You can aggregate and summarize data. And overall, you can build the backbone of data-driven solutions. Before I let you go though, I would like you to keep in mind that there are a couple of query optimization tips that you can use. You must always use proper data types. That means that if you insert integers into a column, make sure that column accepts only integers. If you insert text values, make sure that you're running varchar or text columns and stuff like that. You must only read only the necessary data for your queries to be performant. So for example, instead of using select all, you use select column. You can filter your data with where and or the query clauses we went through. Filtering your data allows your database to minimize the amount of accessible data and makes your queries faster. You can use indexes to make your queries even faster, but also keep in mind that queries will only use indexes where they're used for. But also keep in mind that queries will only use indexes where they're necessary. So if you don't have tens of millions or hundreds of millions of rows, indexes may not be necessary for you. You can also limit results when appropriate. So instead of select all from table, you may use select all from table limit 5, and that instructs your database to only return 5 rows. And you must also read the documentation because not every database management system is made in the same way. So always read the documentation before proceeding to do something, no matter if you use MySQL, SQL Server, PostgreSQL, Oracle, or other database management systems. So to recap key concepts, a database is an organized collection of stored data. SQL is used to interact with relational databases, right? So CRUD is creating, inserting, updating, and deleting data. We can create tables or databases by issuing create database or create table queries. We insert data into tables with insert into query statements, and we update and delete data with update queries and delete queries. We filter data with where. We combine some sorts of result sets with and. We can use or not to exclude some sorts of results. We can sort results by order by and limit results using limit. We can use aggregate functions and grouping if we desire. So count will basically count every row in a table or in a column depending on how we set it up. Sum will sum up everything within a column. Average will return an average value. Min and max will return minimum and maximum values. And also group by will group by a specific column. Subqueries are queries inside of queries. Aliases allow us to temporarily rename columns. So if we use as column 2 on a column, that column will be column 2. Indexing makes our select queries faster at the expense of making deletes, updates, and inserts slower. And transactions and rollbacks are meant to either tell our database to save data or to roll it back, basically undo the changes. Now you know a little bit about relational databases in SQL. I hope that you enjoyed this tutorial. I hope that you will share this tutorial with your friends if they also want to learn SQL and databases, and I will see you later.